Alright, so this is going to be lesson 3, and we'll be focusing on page 97. So we're dealing with tangents. So now the derivative can be used. Remember, rule number 1 of differentiating can be used to calculate the gradient of the tangent of a graph at any point on the graph, right? So now if you can check the graph given here, it's going to be the graph of f, right? And we have our linear graph or a straight line graph represented by the equation of y equals to mx plus c, right? Remember that m is going to be our gradient, then x and y will be any given points on the graph, right? So now it means that a is going to be our x value, which we would have to substitute in the graph of f, right? So meaning that in order to find the gradient, we're going to use this formula of the gradient is equals to the derivative of f with respect to a, where a is going to be our x value, then f prime or derivative of f is going to be using rule number 1 with the given equation, right? So with that given equation, we have to find the derivative. Then after getting the derivative, we have to substitute what? We have to substitute a, right? So remember at the end, our equation of our tangent is going to be y equals to mx plus c, right? So now here we have an example. It says determine the gradient of the tangent to the graph of f of x equals to x to the power 3 minus 2x to the power squared plus 3 at x equals to 2, right? So meaning that with this given equation, we have to what? Find the derivative of what? Of f. Then our gradient m is going to be equals to the derivative of f. But at the end, we're going to substitute what? A. So it's going to be y with respect to a, where a is going to be our x value. Now let's check. So now to find the derivative, we have to differentiate this equation. So it's going to be the derivative of x is equals to 3x squared minus 4x, where 3 is going to be equals to 0. Then from there, we know that m is equals to the derivative of of y with respect to x. We know that m will be equals to what? 3x squared minus 4x. But we know that x is equals to what? X is equals to 2. So we have to substitute what? 2 after finding the derivative of x. So we have 2 to the power squared minus 4 multiplied by 2. Then our final answer is going to be 4. So meaning that our gradient is going to be 4. The gradient of a tangent is going to be 4 when x is equals to 2. Right, so now what happens if we have to determine the equation of a tangent, right? So remember, your tangent is going to be a straight line, and previously we said it's determined by y equals to mx plus c. So now the equation of any the equation of any straight line can be determined by using the following equation, right? So it's going to be y minus y1 is equals to m multiplied by x minus x1, right? So now if you can check here, we have m. So m is going to be the gradient of the line, right? Then x1, y1 are the coordinates of any point on the line, right? So meaning that this is going to be the equation of your straight line. But now in order to determine this equation, you first have to find the gradient, and after getting the gradient, make sure that you use any given coordinate, or you have to find those coordinates, either the value of x or y, in order to have these two coordinates at hand so that you can be able to solve using this equation to get your equation, right? So now it means that if any x value of any point on the graph is given, right? So we can find the y value by using the original function f of x, meaning that the given equation that is given to us, we're just going to substitute what? The value of x to find the value of y. So meaning that here when I say y is equals to f of x value, it means that we're going to find y value by substituting the x value on the function of f, right? So it's just substitution to find y. Then from there to find the gradient of the tangent, as I've said it on lesson, on the previous part, is that the gradient can be established through what? Through finding the derivative of f with respect to what? To x, substituting the value of x in the derived equation to find m, right? So this is just going to be notes only on how to solve or how to find the equation of a tangent using a gradient in any point on the line. Right, so let's look at this example. So the example says that determine the equation of a straight line. Remember, equation of a straight line, it's y minus y1 equals to m multiplied by x minus x1, where m is going to be the gradient and x1 and y1 is going to be any points on the line, right? So now remember, in order to calculate the determine the equation, first we have to ensure that we have our gradient in place. Also we have the x value and also the y value, right? So now let's check. It said determine the equation of a tangent to the graph of f of x equals to x squared minus x at x equals to 2, right? So now what do we have? We have f of x, then we have x, which is 2. So meaning that we have our x coordinate, which is 2. Gradient, remember gradient, we're going to use gradient, we're going to find what? The derivative of a in terms of x, right? But y, we do not have y. Remember, to calculate y, we just have to say y is equals to f of the x value, meaning that we're just going to substitute the value of x. So let's check. So now the solution here is going to be, we're going to use our equation of f of x minus 3. This is going to be minus x, right? Now to find y, remember f of x is y, right? So we're just going to substitute what? We're just going to substitute the value of x to find y. This y value of our equation. So it's going to be 2 to the power 2 minus 2. So 4 minus 2 is going to give us what? It's just going to be 2, right? Then from there, what do we have? We have the following. So now that we have our y value, which is 2, we are sorted. It means that we have our x1, y1, but now we just have to determine what? The gradient of the tangent. So meaning that we're going to say, so meaning the coordinates here, it's going to be 2 is 2, 2. Right. Now from here, what do we have? We know that to find our gradient is equals to the derivative of f with respect to x. Then the derivative is going to be, it's going to be x squared minus x. So this is going to be 2x minus 1, right? So this is going to be the value, right? So now with that, we're just going to do what? We're just going to substitute what? The value of x in our equation. So remember here, x is equals to 2. Then just going to substitute 2 minus 1. So 4 minus 1 is equals to 3. So meaning that our gradient is equals to what? Is equals to 3. Our gradient is equals to 3. So now we have the coordinates of x1 and y1, and here we have our gradient of 3. Now if we have to determine the equation, so this is going to be y minus y1 mx minus x1. Y minus, we know that the y value is what? Is 2. our gradient is what is 3, then x minus x1 is going to be 2 as well. So it's going to be y is equals to 3x minus 6 plus 2. Then our equation is going to be 3x minus 4. Remember, you transpose 2, you multiply 3, and x is 3x. 3 multiplied by negative 2 is negative 6. So this is going to give us minus 4. So the equation of the tangent is going to be y is equals to 3x minus 4. Alright, so now let's look at this example. It says that the graph of f at x equals to x minus 2x squared has the tangent with a gradient of 9, right? Then B says determine the coordinates of the point of contact between the tangent and the graph, and also determine the equation of the tangent. Right, I was looking for the graph, but it seems like I placed it somewhere. So now the point of contact, it's basically saying that this is the graph and this is going to be the tangent and point. So this is the point of contact, right? So the point of contact, it's where your tangent and the graph meet. So basically we need to calculate the x and y coordinates, right? So now here we have an equation of f, right? And we have our gradient. Remember, m is equals to the derivative of what? Of f in terms of x. So meaning that if our gradient is already given, so it means that the derivative of f of x is equals to 9, right? So now let's start with this one. So now here we have to find x and y, right? So now in order to find this one, we're going to say, so f of x is equals to x minus 2x squared. So to find the derivative of x, remember we just have to find the derivative of x. This is going to be 1 minus x, right? So it means that the derivative of x, of f, it's going to be what? It's going to be 1 minus 4x, and we know that the derivative of f is equals to what? To the gradient. Therefore, we know that derivative of f is going to be 1 minus 4x, then m is going to be a gradient, which is going to be 9. Then we're just going to transpose, so this is going to be 4x, this is going to be 1 minus 9. Then we're going to have 4x is equals to minus 8. Therefore, the value of x is going to be minus 2, right? So it means that we firstly had to find the derivative of f, which is equals to m. So here's the derivative of f, which is 1 minus 4x, which is 1 minus 4x. Then we know that m is equals to 9. We just solve for x. Then we know that x is equals to 2. So remember, we have y is equals to y1, then m multiplied by x minus x1. Already we have sorted, we have established x1, and we have m. We just have to calculate y1. Remember, for y, we're just going to substitute minus 2 on the original equation. So this is going to be minus 2 multiplied by minus 2 to the power squared. So this is going to give us an answer of minus 10. So it means that y is equals to minus 10. So it means that the point of contact, therefore, the point of contact is going to be x value, which is minus 2, and y value, which is minus 10, right? So remember, points of contact, it's basically talking about x and y value. So let me just highlight it. Point of contact, this is x1, y1. So we have to find x1 and y1. From the original equation, we know that gradient is equals to the derivative of f. Then we know that this goes to 9. Then after finding the derivative, 1 minus 4x, we just have 2. Solve for x. To find y, we just substitute negative 2 on the original equation. Then we have the values of x and the value of y. Then number 2 says determine the equation of the tangent. Now that we have determined the value of x, y, and we have the gradient of the tangent, which is 9, we can be able to substitute. So this is going to be y, so it's going to be positive 10. Gradient is 9. X, y is minus 2, so it's going to be positive 2. So you're going to have 9x plus 18. Then it is going to be minus 10. Then you have an equation of 9x plus 8. So that is going to be the equation of the tangent.